Hi everybody, I'm Ms. Lee. In this video, we're going to go ahead and talk about dividing complex numbers. So when you're dividing complex numbers, one of the most important things that you need is to know what a conjugate is. So in math, conjugates are basically where you flip one of the signs so that when you multiply them together, the middle term adds up to 0, and you basically get kind of like a difference of squares thing going on. Okay, so I'm going to go ahead and just put this as your keynote right here. So the conjugate of a plus bi. So you know that complex numbers come in the form of a plus bi, where a is the real part and b is the imaginary part. And so the conjugate is just where you flip that sign, so from being plus to a minus, or a minus to being a plus. And so this is like a two-way statement where you can say the conjugate of a minus bi is a plus bi, and the conjugate of a plus bi is a minus bi. Okay, so we're going to go ahead and do an example problem. Okay, so we're going to do 3 minus 7i divided by 2 plus 6i. So for those of you who think that you can simplify this by just doing, let's just do 3 over 2 and 7i over 6i, that is not okay. Do not do that. You cannot do any kind of thing like that unless it's multiplication, but here it's addition here in the denominator. And so we're going to need to find a different way to go about doing this division. And so what you want to do is you generally want to get rid of the imaginary number from the denominator. So you do not want an imaginary number in the denominator. And the way you do that is you multiply by the conjugate of the denominator. Okay, so when you're dividing complex numbers, you want to multiply the numerator and the denominator by the conjugate of the denominator. Okay, so the conjugate of the denominator is going to be the conjugate of 2 plus 6i. So the denominator is 2 plus 6i. And so what is the conjugate then? Well, you're just going to want to flip the sign. And so we flip that plus to a minus, and so it's 2 minus 6i. Okay, and so we're supposed to be multiplying the numerator and the denominator by 2 minus 6i. And so some of you might be asking, well, why do you multiply the numerator and the denominator? Well, if you think about that, when you multiply the numerator and denominator by the same thing, you are not changing the problem. You're basically multiplying by 1. And so that's what we want to do so that we don't change the problem. We just want to simplify. So we're changing in a way that just simplifies the problem, but it doesn't alter the original problem. Okay, and so what you'll want to do is you want to make a box for the numerator. And you want to make a box for the denominator. Okay, so depending on who your teacher is, depending on who taught you how to multiply binomials, some of you might have heard the words Punnett square, area model. Those are all the same thing. So I just said box because that's, easier. So for the numerator, we'll go ahead and have 3 minus 7i, and then 2 minus 6i. And then for the denominator, we'll go ahead and make our box. And so we have 2 plus 6i. And then we have 2 minus 6i. Okay, so we're just going to go ahead and multiply these through. So we multiply each of the terms together. So you have 2 times 3 is 6. 2 times negative 7i is negative 14i. 3 times negative 6i is negative 18i. And then negative 7i times negative 6i, that's going to be positive 42i squared. So some of y'all will leave this as I squared. That is not acceptable because we talked about what the powers of I would be. And so you should know that I squared by definition is actually negative 1. So this is basically the same as 42 times negative 1. Well, what's 42 times negative 1? Well, this will just be negative 42. So we'll go ahead and just add those all together. And so you have 6 plus negative 42. That's negative 36. And then minus these two added together. And so that'll be minus 32i. And so again, this is the numerator. This is the numerator. And in the denominator, we have, and so remember, this is where we had 2 plus 6i times 2 minus 6i. And so this is where we did the whole multiplying by a conjugate thing. And so you're going to see something really cool happen. And so we have 2 times 2, which is 4, 2 times 6i, which is 12i, and then 2 times negative 6i is negative 12i, and then 6i times 6i is negative 36i squared. And remember, we said I squared equals negative 1. And so basically, negative 36 times negative 1 is equal to positive 36. This is positive 36. And so you're going to notice that, oh, look, there is a 12i and a minus 12i. And so this adds up to 0. And so this is the point of multiplying by a conjugate, is having those imaginary numbers add up to 0, so you end up with no imaginary number, because we want no imaginary numbers in the denominator. Okay, so we'll go ahead and add this up. You have positive 36, positive 4, that adds up to 40. And you have 12i and negative 12i, that adds up to 0. And so 40 is just a real number. And so when you combine these, so one in the numerator and one in the denominator, you're going to have negative 36 minus 32i divided by 40. And what you'll notice here is that this can be simplified. So the 36 over 40 and 32 over 40 can be simplified. And so you're going to have to simplify that. If it could not be simplified, you can actually leave it like this. But because there can be simplifications, what you have to do is split the denominator. So this is equivalent to negative 36 over 40 minus 32 over 40i. And so we'll go ahead and simplify that. So negative 36 over 40, we divide both the numerator and denominator by 4 because that's their greatest common factor. And so we have negative 9 divided by 10 minus, and then we divide 32 and 40 both by 8 because that's their greatest common factor. And we have 4 over 5. And so you can write I after, and you will have 4/5 I, or you can have 4i over 5. Okay, and so this is your result. There are no imaginary numbers in the denominator, and we have successfully divided complex numbers. Please let me know if you have any questions. Happy day.